Good morning, everyone. I like to start all my things with quotes, and I think about that. Albert Einstein's my favorite. Lots of times I kind of look like him. I'm not nearly as smart as him, but my hair is usually a little crazy every once in a while, so I've adopted him as my friend there. But I do believe that imagination is more important than knowledge, because it's funny, working where I work now. When I first started 19 years ago, come next month, they made me take, along with every other employee, not only me, I wasn't singled out, even though I felt that way. I had to take 3 personality tests. I guess they weren't sure what kind of my personality was. I could have told them what I was before I got started, but they had to check, right? And in every one of them that they took, anybody that did analysis of it, they said I should have never become an engineer. Well, they were right. I started out, I always tell everybody, I am a reformed architect. Okay, that's my initial degree in architecture. Unfortunately, I designed ugly functional buildings. So that, doesn't really bode well for becoming any sort of a good, architect. But I figured being around Italian and being around construction almost all my life, becoming an architect was the right goal to have. And then then at some point I realized, well, I was never going to be happy doing someone else's designs, so I went ahead and I just became an engineer. But they said, because I was too artsy, or in the one that we currently use, which is the people mapper, I'm a free spirit. If anybody knows what a free spirit is somebody that cannot color between the lines. Okay? Right? And if the one thing about being a free spirit is that I thought that made me a better engineer by being a free spirit. And the reason I say that is because every design I've ever done in my life is the way I did it today is not the way I'm going to do it tomorrow, and it's not the way I'm going to do it the following day. I'm going to make them better every single time, at least hopefully in my mind. So, but again, I go, well, opinions are like something else we all know. Everybody has one, and I go, well, they could think I'm not a good engineer. But anyway, I thought this was an interesting thing, and about the gentleman sitting on the throne thinking about things, and I really do hope that the Lightning will three-peat. They went on a little slump for a while, but we'll see how they do. All right, I'm not going to read about what these things are, but if you really care about what our learning objective is, you're going to learn something today, I hope. Either you're going to learn that I talk too much, as everybody that works with me knows, but the whole point of you're going to start to see a theme going on here, by the way, if you haven't figured that out. But today we're going to talk about the steps of an audit, the outcome of an audit, the owner's perspective, M&V, winners and losers, lessons learned, and what's going on today. Well, the reason I bring this up is interesting. I thought about it too late, or otherwise I would have put a slide in of me doing a presentation on this same facility 3 years ago here. Only difference then is that I did it with the owner, and it was just at the end of the beginning of it. Some of the work still wasn't finished. So I thought about, we can do it as a case study. And actually I had asked the owner. Now the one thing I can't do is, because they are not with me, I can only say it's a large financial institution. I can't use the name. When they were with me, I could use the name, but they're not here. There might be some guys with SWAT guns or something. They're going to take me out if I mention their name. So, but hint, hint. You can go back online and look at my presentation 3 years ago, and you could figure out who it was. But I don't suggest you do that. All right. So, I was asked. We've been doing work with this client forever. And they said, hey, could you do an audit for us? And we said, sure, we can go ahead and do this audit. But like I said here, we've been doing work for this client since about 2010, and it started by adding a convault tank so now I think it gave them 15,000 gallons of storage for fuel oil, and they have 3, I want to say 2 meg generators that can run the entire facility, because seriously, they're a financial institution, and going down and being without in any kind of a power outage is a no thing. So that was the first thing that we did for them. But what I didn't know at the time is that we were hired part of a 3-state audit. I didn't know I had competition, or otherwise I would have known I was going to beat them anyway. But hey, listen, you got to be confident in what you do, and you think you're good at what you do. And it turned out, seriously, all kidding aside, ours was the most successful, and that's the reason why this particular client is now having us do work in New Jersey and in Texas. So, one of the other things, I'm just going to tell you, if you've ever done an audit before, there's a handful of things that you have to do. If anybody that sat through my class the past 2 days, I talked about how to do an audit, right? So the whole thing that you have to do is that you have to outline what the owner's expectations are. That is completely the most important thing. The actual work, I think, almost all auditors can do work. But you have to understand what the owner wants, because at the end of the day, that's what they're paying you for, to give them what they want. Sometimes you have to guide them, because they don't know what they want. I was very fortunate that my client was an engineer. He actually worked on my, so he kind of knew what he wanted. And let me tell you, that is a blessing and a curse at the same time. Because, you could do all these things, and most owners, and like I said yesterday, when you get the executive summary, make sure it's no longer than 1 page, and you want it concise, and you want it very to the point, because that's all they're going to read. If you go beyond that 1 page, they're yawning, they're sleeping, no, this guy he would ignore the executive summary. He would go into the details, the graphs, and Al, on page 37, this calculation doesn't look right. I go, all right, I love this guy. I hate this guy, but I love this guy. Because it keeps you on your toes, which I think is great. He's, in all sincerity, he's challenged us. Like right now, he's trying to figure out how we could take heat. This is in New Jersey, on some of the units, on heat pumps, of where we can heat the buildings up by he's got a looped system on one floor of how we can reject heat at night back into the space to keep it when it gets cold, because it's cheaper than using fossil fuel. So it's like he has us doing all these interesting studies that we ultimately have to do for him. But it's a great client. So, the first thing is you got to sit down and you got to find out, what did you find out when you sat with them. The one thing we did learn is that they really were interested in sustainability. They were really interested in resiliency. These were all terms. In 2016 was not a big term, resiliency. I asked the class yesterday, what put the word resiliency on the map? Come on, somebody here could tell me. Was that? Data centers. No, not the type of facility. There was a specific event that brought it to the forefront to everybody's mind because of what happened. Yesterday, the other day, somebody said the outage in Texas, the freeze, that was the second one. The first one was Hurricane Sandy. Think about what it did to the Northeast. It devastated, it shut everything down, and right after that, resiliency became a big thing. But they were big into resiliency way early. They wanted to listen to our ideas. They said, the facility could never go down. That's why they have these, they had redundancy. They didn't need the 3 generators. It's that if one generator failed, they can go to the second generator. If that failed, they can go to the third generator. Okay, so this was like, failure is not an option. We've all heard that term. Well, they took that to heart. They really cared about their carbon footprint. We had to do the whole thing with no shutdowns. But the thing that was most important, I didn't realize that was our unknown goal, to achieve energy savings in their facility. And the reason I say that is that, he set it up for us to do the audit. He had a corporate goal of 10% across his facilities to, by 2018, because this was starting using 2015 as a benchmark. And we were going to see how that was going to go. And it turned out, as you'll see in a little bit, that we far exceeded that. Well, now the audit begins, right? You have to do all the energy modeling. You have to look at how the weather reacts. You have to start calibrating the model, and you got to figure out all the different places of where energy is being consumed on how you can, save their energy. Then you start to look at, we started with, everybody says you have to do a calibrated energy model. You don't always have to do it, but we had one to start with because of, they wanted us to look at helping upgrade the central energy plant. They wanted to try to convert it from, right now they had N2 to go to an N+1, and it was not designed to be an N2, it just turned out. They had 3 550-ton chillers, and they never used more than one in our energy model when we did it because their trending was terrible. Anybody here has ever been involved with trying to do trending on a building? Yeah, I would get 24 hours, and this very sophisticated client didn't have trending, which was like crazy. So anyway, but the blessing that we had, and I'm sorry to say, Mike has passed on now. He could tell me, because he was one of those facilities managers. He named the chillers. He loved them like they were his children, and he could tell me anything that was going on with that facility. So we kind of I said, so Mike, you ever run more than one chiller? He goes, nope. And he goes, and Allie, it doesn't even really hit the 550. I said, okay. What do you ever see it go down to? He goes, we get down to maybe whatever it was, like 200, 300. I said, okay, well, that doesn't tell me a whole lot. So we did this energy model, right? Because they wanted to look at what was going to happen. So we did all these things, and I even looked at putting thermal storage for them because they wanted to look at sustainability. Now, the interesting thing is that there is, it's kind of counterintuitive when you're thinking about thermal ice and calling it sustainable, right? Because you use more energy to produce ice. Chillers are normally, 0.5 to 0.6. When you use them to make chilled water, it's 0.9 to 1 kW a ton. But, the reason that they do it is that because you get savings from the utility companies, because you do things on off-peak hours, which are normally a lot cheaper and things like that. So there's reasons for it. But we looked at everything. Like here, you can see we even looked at the water. We went through in all different ways of how they were saving water and how they could save water in their plant. Now, as you go along, a lot of things just start to crop up, and we use the energy model to come back with developing the ECMs and confirming what we had as our assumptions of what we can do and how they would work. And then what they did is they kind of confirmed our hand calculations for any, I did use spreadsheets, but we call them hand calcs. Because in the old days, we did everything on a piece of graph paper. Believe it or not, it's like I did not do everything on a stone tablet as much as everybody has a fond way of thinking that, even my drawings were made up on stone tablets. Well, after you're done with all of that, the ECMs were kind of made up when we came up with a bunch of, I want to say there was like 20 of them. And now you sit and you eventually you'll meet with the owner. And then, the other thing is you have to create the report. Sorry, Mark, I had to at least show the old logo. Oh, he's not here. He already gave up on me. Yes, he's next door. I guess he sits on that board. He should go next door and see the other one. But anyway, so that there is the report is prepared. Then the next thing that comes up is, you now have to meet with the owner. So you have to go before them, right? But this is really what it's like when you go meet with the owner, But the way I looked at it, now I'm going to give them an offer that they can't refuse. I'm going to show them how they're going to save energy and how their building is going to be better, and I want them to believe it, because I believe it. You know, I don't say anything I don't believe. Anybody that knows me long enough knows that, you know, one, there's no filter between my brain and my mouth. It's a good thing and a terrible thing. I will tell you that from all sincerity. You know, it's gotten me in more trouble than I care to admit. But anyway, so this comes directly from the report. So we told them that they currently use like almost 6 million kWh. Their current bill for that time frame was almost $550,000. I said that they would save 30%, and which would be account to, based on that on money, would be almost $200,000, right? So now, you remember a few slides back, I had this unknown goal of 25% of what they thought I was going to do. And I mean that, I'm not saying that just for what was the word I'm looking for, to be theater, if you will, for drama. No, I really didn't know, honest to God. I had no idea. I actually didn't find out that my goal was 25% until Nick and I actually did this 3 years ago, and that's when I found out that I had a goal of 25%. So we did it, and we did 30, which was what we predicted, right? And then, you know, there's followed, you know, the next thing that have to happen. We did just a little quick chronological order. We did the audit in 2016, which based everything, our baseline was 2015. In 2017, we implemented 5 ECMs, demand control, static pressure reset, etc. You can see, I'm not going to read them all. And then we did the most important one, at least in my mind, which was the retro commissioning process to them. You know, it's funny, when you do a retro commissioning process, and actually I have to say our illustrious test and balance company is sitting right in the front row right there. He's waiting in an appropriate time to heckle me, I know that. But what we found is we start out, I think, as a commissioning agent, and this is the beauty, I think, of you can call it the holy or the unholy trilogy of the three of us together, ACG, AABC, and the EMA, is the fact that, you know, you need all three to make this work, right? So when I went ahead and we did this, we always we do 25% of everything, or 100% of the air handlers, chillers, and things like that, but 25% of the boxes. We did 25% of the boxes, and 100% of those boxes were not calibrated. They were completely out of whack. So now we go, I mean, and we figured this on in the first 25% of the 25%. You know, you start to see a theme, right? Because it wasn't just like 25% and we did all, let's say, you know, I think there was like 250 boxes. Not like we did that 75 boxes, you know, in one air handler. You know, we were doing them, and we started to see this trend. So we immediately go to the owner and go, hey, do you want us to like engage my friends and we should do more of this and do it all? And they go, oh yeah, without a doubt. So that's when you know you have a really good owner. He didn't just go, how much, before I think about it. He goes, do it. And then he said, find out a cost for me, would you? It'd be kind of nice to know. We have to put it in the budget. Not a problem. So we did that. And then the central energy plant, which I'll talk about in a little bit. And then they did a LED lighting upgrade, which also included daylight harvesting. And then we did the commissioning of the central energy plant when it was done. And that was an interesting thing. But anyway, so now you start to look at, you know, what happened. So these are actual from the trends of showing, and we found some interesting things. The one thing, you know, if anybody here knows what static pressure reset is, right? Well, you know, if you ever wonder if it works, it works. We found air handlers that would normally set at 1.5 inches all the time. We saw some literally go down to 0.6 and sit there most of the time. So think about that. If anybody, you know, I'm not going to go through the fan affinity laws, but just think about it. If you cut by 20%, you know, the energy savings is phenomenal. of what happened. It didn't happen to every air handler, it happened to a lot, but we did find that a majority of them sat, where we're usually at 1.5 inches, they sat at 0.9 or 1 inch. So, you know, it really does work. So it's to start the interest in things and you start to see the trending. You know, commissioning is a great thing and I love it and I've been doing it since 1998. But the one thing I think is interesting is when you go out in the field, you know, you can make things, you can simulate things, and, you know, I was the guy that would, yeah, let's try this and let's try that and let's see what happens when you do this. So it's like everybody here has been told that you know, running 2 pumps at the same time instead of 1 pump because of the pump affinity law saves energy, right? You've heard that forever and ever. Yeah, they're full of crap. That, you know, not that I think the law is wrong, you have to understand the pump curve. If the pump curve is very steep, then it works. If you have a very flat pump curve, it doesn't work worth a damn. So you know how I figured that out? Not because I'm so smart, because I'm really not. I'm the guy that would go, okay, we're running it on 1 pump, go to the VFD, it gives you the amps, it gives you the KW, it gives you everything that you need. Okay, let's start the other pump. Let's get the amp, and after it settles out, let's get the amps, we'll get the thing, and you compare the 2. We always use more energy with the 2 pumps than we ever did with 1. So so I'm not the guy that's going to start heckling people and tell them, yeah, you're full of crap and it's not the right thing. I just said, no, look, I've just proven to myself. I mean, you know, it's like I'm the guy that has to. I'm the hands-on guy. You know, like I said, I was the architect. Remember? So I always think it was funny. Anybody here remember the movie The Towering Inferno? I've never met that architect in my life that could stick his hand into the panel, which was kind of stupid anyway, into the electric panel and pull out a wire and go, hey, this is not the 5-aught wire that I designed around. Okay, I've never met an architect that I can even show him, he could tell me what wire is, but let alone that. And so I just thought that was kind of like an amusing thing, or like, you know, commissioning agents, mechanical people, you watch all the Bruce Willis movies or the Arnold movies and you see smoke coming off the pumps. How does that happen? You know, I mean, really, give me a break here. How does that happen? But, you know, but again, it's called, you know, theater, right? I guess what I'm doing now is theater, I guess. But for the most part, does everybody like where I've gone with my little thing? You know, I try to make it entertaining instead of having boring white slides, right? If anything, you'll go, hey, at least it was colorful, I wasn't bored. So anyway, you know, it's just kind of funny, the promise. That picture, when I was looking for things to put on there, that promise, that particular image was talking about that the weight of the world is on that person's shoulders. And I thought at that point, I put that promise on my back to this client, that I would do this. You know, at some point, you know, in life, when you make a commitment, you have to put your money where your mouth is. And that's what I had to do. You know, so what was the promise? You know, they went through, like I said, I had like 20-something ECMs, and the owner goes, I want to do 1, 3, 4, 7, 11, and 13. Okay, that's what you're going to get. So that's what we did, and we did things. So we said they would reduce. So you've seen all the things I've talked about already. And so what really happened, right? That's the outcome. What really happened? This was the promise. What did I say? We said we were going to get down to 4 million kilowatt hours, right? That's what I told them. That's what I promised. Well, folks, this is exactly what we did. So as you can see here, the gray is the baseline year. This was the first year that we actually didn't do anything. The owner was still trying to do things, but here you can already see that we started to dip down to get close to the promised goal, right? And the only thing is you can see right here, you see how this dipped down? That was, believe it or not, that's the start of the retro commissioning process. That was where the start was. Then you see here, this was the first full year with the ECMs, which was the 2018. You can see where we are, right? Now, I put in 2020 and 2021, and don't get me wrong, there was phenomenal in the amount of savings that is there, but I don't want to, I took them as outliers, because you have to. 2020 and 2021 were, anomalies. And hopefully we're never there. I mean, it's always going to be different. We'll have a new baseline at some point. So right now I would consider, 2019 is our new baseline. But as you can see, with 2020 had already shown, because don't forget, the 2 weeks to flatten out the curve, that would, okay. We won't go there on that, folks, but, we already started to see, they were already marketed amount. People did not go away in the first couple of months. So, so it gives me a lot of hope that once the building, because they're back into the facility now, that when we look at 2022, we will see they'll be somewhere in here. And while I believe that they'll be in here somewhere, but you can't use it. But I thought that was interesting. Now, anybody that took my class says the one thing you should never, ever use as a metrics for a basis to talk to the owner, even though you want to tell them about money, but you should never base what you're doing on money. There's a lot of reasons for that, and I'll show. So now, this was the slide just to give you a little different version of how you can see this stepping stone from year by year. And now we said, even though I said we should never talk about money, when it really is to your advantage, you should still talk about it, right? It's still impressive. But so when you look at it, we said we would save them about $200,000. So if you haven't figured it out, there's going to be another slide just like the one before, and it's going to show the same kind of things with the same kind of guideline of where things are. So you could see literally in the first year of ECMs, in the first year of ECMs, we really got there. It's phenomenal, right? And I went ahead and I made this the new baseline year, and you can see that the money was kind of tracking, but I think that is equally as impressive when you start to look at it. And you'll see us in a slide why, using money, that gentleman right there sat in my class, and I said, why not to use it, because things could change. Like one of the examples I used was Texas, right? Texas didn't have any reciprocity with any other utility company. So when they had that frost, what was it, last year? And it kind of shut down the state, okay? So because they had no reciprocity, the cost of power is very expensive. It's very cheap when you're doing it yourself, but when it has to be done different ways, it becomes very expensive. So your electric bill one month could have been $200, and the following month during that crisis, it could have been $3,000. So, but that's why you shouldn't use money as a means of looking at it. Again, there's that same graduated sum. The reason I didn't put 2021 money in there is because they had only given me the money up until, it's not that they wouldn't share it with me, they share obviously every other number. They just didn't have them. They gave me, when I asked for the rest of the year, they just didn't give me the money. That's the reason I didn't put it in there. And I tried to extrapolate things, and I go, yeah, no, it's not going to be right. And one more year is not going to prove. I think I've proven a pretty good point as it is. But here's the average cost of the utility. So if you see here, this is why you don't do it. Right? When I started, everything was based on 9 cents. And as the last year, it was based on 6 cents. This is not this isn't stuff I made up. This is from their electric bills. I just averaged them out. The whole year, an average cost. So, it's hard how things are going to prove out. But, you got to think about it. I told them, think about what I said to them. You follow the path that I set out for you. Your electric bill is going to go from $550,000 a year down to $250,000 a year. It's less than that. It's less than that. But, so it was definitely I think it was a wonderful thing that they wound up doing, and they were a great client to work with, and they still are. And, you live your whole career to work with certain clients that embrace what you want to do. They are supportive of what you want to do. They love your harebrained ideas because they got crazier ones than you do. And it's like, I love that guy. He makes me crazy, but I love that guy. This also came out from Nick. You don't know if you're winning or losing until you start keeping score. Right? I'm a baseball guy. I'm a Yankee fan. If you're a Boston fan, I'm sorry for you. Not because I'm sorry for you that you're a Boston fan, but it's because I'm a Yankee fan. And but I tell everybody, I'm a baseball fan first. I'm a Yankee fan second. I'm a Rays fan third because I live in Tampa, and anybody who's playing the Red Sox. So those are in that order in particular. So, but born out of this, we kind of found a few things that came out with the meeting. Like I said, static pressure, right? We talked about that we're always set at 1.5 inches now at 0.9 to 1, some down to 0.6. The retro commissioning process clearly saved more money than predicted. Think about all the VAV boxes that were completely out of whack. The thermostats were not right. We just found, it was literally the poster child of why you should do retro commissioning. Some of the other things that we did when we did the CEP upgrade. Now this is the most fascinating thing. We did 550 tons was their existing thing. We wound up saying, all right, we'll go to N+2, right? They have 3 chillers. They're going to replace them. We'll do an N+2. So it was between picking a 250-ton machine, because we did, again, this owner was looking for his best bang for the buck. We did the chiller purchase as a life cycle cost analysis. So when we sent it out to the vendors, they literally we gave them the bin hours, and we gave them the cost of electricity. They had to put their KW at the travel points for each one, 10%, 20%, and so on. And we got the pricing, and the owner did not pick the cheapest chiller. He really did not. He looked at what was going to be the best for their facility. Well, it turns out, now, what did I say, right? We did the energy model. The energy model proved that the base load was about 450 tons, right? And so it kind of went along with what Mike Ressasol had told us, that he never really saw the 550 at any time. And I said, okay, so hey, everything looks right. Well, they did the lighting upgrade. They do all these things. The plant never uses more than that one 300-ton machine. It was kind of interesting. When I went ahead and engineers, we trust the laws, right? We trust the laws of physics. I always tell everybody that, when they talk about the colleges they went to, and I remember I told you I'm a reformed architect, right? So I've been operating, my entire career is based on high school physics. That is my career, has been based on high school physics. It's amazing how the laws don't change. So what I found out of doing this, we had the cooling towers each cooling tower was 550 tons. We had 75 horsepower motors for each of those, because again, they were where the towers were located, the water they had to move. I replaced them with 15 horsepower motors. Yeah, Alyssa's not in the room, who helped me with the calculations. She did them. No, that's not right. Please go back and recheck that. Can't be. I did them. No matter what I came up, it was right. We did it. We took 100 horsepower motors and we put in 30s to distribute the chill water to the plant. Again, I didn't sleep a lot of nights, especially, and then when we finally agreed, they buy it, they're putting it in, and they're about to turn it over, they're going to turn the key over. boy, I was turning white, I was sweating. I was like, okay, you know, you believe in the engineering, and I mean that sincerely. I believe in the engineering. But I went from 75 horsepower motors to 15. I went from 100 to distribute to a building that was literally across the street to 30s. So, and then the sad part about it is when it starts up, and Alyssa was here because she was there, and she's the one that found it, and I wish she would be here so she could take a bow for that. It starts up, and the chillers don't work right. Things aren't working right. We're not getting the water out to the building. So now, like, I don't panic much. It's not in my DNA. That's not my, you know, I'm the guy that figures it out. I'm the get-her-done guy. So and all of a sudden Alyssa walks away because I'm kind of freaking out, trying to figure out what's going on. And she walks over and goes, psst, psst. So I walk over, he goes, that valve's open. Color back into my face. Yeah, it was a bypass. Everything was staying in the plant. It wasn't going anywhere. I'm going, okay, we're good. I'm back. The laws are good. God is great. The laws were good. You know, all things I knew about physics were now back in line. Before I was freaking out. The cooling towers worked great. The 15 horsepower motors was more than enough. Again, it makes sense because a lot of it makes sense when you think about it. We were pushing, you know, I had 550, I'm pushing less than half the water I was pushing before. You know what I mean? There was a lot of things going on there. So it made a lot of sense. So we're running on a single 300-ton machine. That is a proud fact. It's proud of them. They were willing to spend the money. They changed all lights. But again, they dropped loads out, and we've seen that in other projects that we've done. So, what were the winners? The winners were the overall retro commissioning process, obviously demand control, which obviously nobody's in the building, so we're not saving any air. You know, we're still putting all the air in the building. ASHRAE compliance to make sure we did everything with outside air. They had some things with crack units that they were running multiple, and I said, yeah, we could probably make it. We had to do some modifications to how their plumbing was in the floor, but real minor things. And they did the lighting upgrade, and then they revised the cooling tower sequencing. But you notice that I said one of the losers was the revised cooling tower sequence. I said it was a winner and a loser. It was a winner when we still had the 550-ton machines, because we did the retro commissioning first, right? The reason why is because if I ran 2 cooling towers, you know, if you follow the fan laws, now the fan laws are definitely in your favor here. You run two of the fans at the same time, less flow across the cooling towers, you use 1/3 of the energy. It definitely worked. I measured it, it was great. But then when we went to one single 300-ton machine, I can't put 150 tons across a 550-ton cooling tower. They'll look like a big snowflake, because they'll just get calcium deposits all over them. So it didn't work. But again, but that fan motor never runs more than about 25 or 30% now, because they're all oversized. Because those were brand new cooling towers that I put in, I think like in 2013. So they didn't want to change them out. All right, the primary corporate goal was to save 10% globally on the portfolio, but they targeted 25% for Tampa, and they wanted all of this done by 2018. All right, so how did we do? We got to the 32% originally, and 2019 we got to 43%. So we're talking about some real energy savings here, and like I said, you know, I took them out, and I said about Tangential, actually our goal, we predicted 30%, we got 32. It's like if anybody was inside, I happened to be standing there when they pulled the thing for ACG, and I won the thing. I should have went and bought a lottery ticket for that too, because you know, how lucky can you get to exactly what you predict is what you get and you exceed it. And that also has to go with when I put down the energy savings, I still understand that human beings are going to run this plant, and we've made a bunch of assumptions on things. So if I said they were going to save $1, and the calculation said, I only told them they were going to save 75 cents anyway, because you have to deal, and again, I don't mean this wrong, you have, things are going to happen, things can run an hour or so longer here or there. There's too many, variables that you can't put in. I don't care how good our energy modeling program is. It is not that good. You can't predict. AI might be good, but Al's not. All right, so lessons learned. Working as a team is definitely more important than working alone. An engaged, energized owner makes all the difference, which it did. That was the first thing I could tell you without a doubt. The owner, believe it or not, the owner has as equally as hard of a job, whoever you are dealing with. Bob Knodler, he calls the guys that make the decisions, the ultimate decisions, call them the C-suite guys. I call them the suits. Because, everybody has a boss. Unless maybe Elon Musk doesn't have a boss. Maybe his wife is his boss, I don't know. But everybody has a boss. So you have to prove to the boss. So when Nick had to go to the higher ups, I had to give him all that ammunition so he can sell it to them. Because again, just because he's an engineer and just because he has these goals and things that he wants to do, he still needs proof. So I gave him everything that he needed. So it's equally as important is to give them, because you got to give them all the tools that they need. The management guys are the toughest guys to deal with because they're not engineers. Engineers will always understand. The other thing I explained in the class yesterday, I keep pointing to the gentleman over there because he sat in class. I said, when you're writing that executive summary, the problem with engineers when they write things, they write these things so super technical, and they think that everybody understands them. Yes, other engineers understand what they wrote. I always tell everybody, write it like your mother has to read it. Unless your mother's an engineer, and that's a whole nother thing, obviously there's always, exceptions to all the rules, but most moms are not engineers. Well, they do engineer a family and they engineer everything else. I'm not taking anything away from the moms of the world. But the point is that the reason I say that is the guy in the C-suite or the suit, he doesn't understand a darn thing about engineering. All he cares about, you see the way I highlighted back a few things, those few things I highlighted in the report about money and savings? Those are the only things he saw in the report. That's all he wants to see. That's all he cares about. Because he's got a million other things he has to make decisions on. So if you think he's even going to read it, you should read it so he can understand what you somehow, hopefully didn't lie to him about. That you're actually what you're going to do. So, where are we here? More lessons learned. Okay. Open and transparent communication. Yeah, I believe in that anyway. I think you have to tell people what's on your mind. You have to tell them if you think something's not going to work, you need to tell them. If you think it's a guess on your part, because sometimes you guess. Engineers hate to say that they guess, but they guess. You assume something, and anybody knows what assuming means, right? We've all know what that acronym ultimately stands for, even though nobody knew it was an acronym. And then the one thing we did learn as a lesson, I said we did the retro commissioning. It was a great thing. And the minute we finished the retro commissioning, you know what the owner did? He went and he replaced the control system. Oh yeah, love that guy. But he did it. At least he stayed with the same company when he did it. But everything that we did, we're now going back and checking. Because, if you really think that, Roger, that was the programming guy, was just going to take all the controls and dump them from one into the other, is what you hope. And he actually read them before he dumped them over and see if they're working. Yeah, they don't do that. They say they do that, but they really don't do that. And so the owner did all this. But obviously it didn't really go too bad because he's still saving great money after he did it. But that even by his own admission, that was the one thing that we should have did, and that the commissioning saved more money than we predicted. All right, so we're going to do some what's going on now. The company, I was not involved in it. I talked to them about it. Actually, I learned it at CX Energy about ISO 50001. They got all their facilities certified, which so again, it shows their commitment to saving energy. But they're looking to improve. They want more resiliency. They want more energy savings. So what they've done is they went ahead, nobody asked them, they put 53 meters in. Every panel they have. Again, remember what he said a while back? You don't know if you're winning or losing unless you're keeping score? Well, think about this. We've now taken a building, we've cut out a substantial amount of energy out of the building, right? So now, when you go back, they want us to, we're about to go do another audit. We're going to re-audit the building. Well, how do you re-audit the building on it's doing a really good building? Well, now with 53 meters, we now know where the outliers are. What's eating up all that energy, and we're going to now target the places that the energy is being consumed. Now, some of it we may not be able to, like obviously if it's there's smaller little data center inside, obviously I'm not going to do much to that. But again, this is the forward thinking of an owner without, we talked about a lot of these things. But the point is, you just have to understand how it works and how they're going to be able to do things going forward. So now they want to add a pony chiller. Remember I told you about that we went from 550 tons down to 300 tons. Well, overnight, the one 300 ton it wheezes and coughs and does all sorts of things because it really doesn't like operating at about 150 tons, not 150, at 50 tons, and because they really are doing really well. So we're talking about adding a little pony chiller, not only for doing that, but they're looking for resiliency. So in the event that there's like a hurricane or something, they can keep all their data rooms and everything up on this little chiller. We looked at it, we're even now looking at potentially besides doing that, and this is where this owner thinks, we're doing VRF. We did a study of doing VRF to cool all these rooms, these little IDF closets and little computer rooms and things. But instead of just rejecting all the heat outside, we're going to use a heat recovery system, and we're taking all of those and we're going to reject heat in the wintertime along the glassed areas so they could, it's in Florida, I know it gets cold like 8 minutes, 3 days a year or something, but it's a great idea. But we're also looking at it, but we're sizing the condensing units big enough that they also could do cooling if they wanted people to come in on the weekends or in the case of an outage, right, that they can do it. But no, they can't just have one. We have to have two. So now if I have a cassette in the ceiling, I have one cassette, and then I have another one next to it. One that's fed off of the A branch of the electrical service, and one is fed off of the B branch of the electrical service, because they have two feeds coming into the building. So, talk about looking at different things. So, and they actually gave us another auditing project to do that, and they want some retro commissioning. And then they're having us look at health and wellness of the building, because that's one of the things that obviously that the pandemic has brought to the forefront of things, right? Of worrying about the health and wellness. So that's one of the things, and they reached out to us early on and they said, hey, we understand there's some things out there. And I said, yeah, we can do, there's the well building standard has this health and safety and ratings system that you can do for a building. You don't have to get full in. And at one point they had us looking at 13 buildings, 10 here and 3 in Europe. is one of the things that they were going to have us look at, and then they kind of cancel. They go, yeah, nobody's coming back to work yet, so like, let's put that off for a while. We don't have to do that. So, but that's something that's coming back. All right, we're at the end of my presentation. Does anybody have any questions? Yes. All right. Let's just jump.
Okay. Well, first of all, thank you so much. That was a great presentation.
Thank you.
Subject. I do have a few questions, but I'll ask the first one and then give transfer the other ones.
Sure.
You was mentioning about the savings of 30% and then you get more, but you didn't tell us anything about the cost to achieve that goal.
Ah. Well, the cost, actually, it's in the report. If I remember, they had to spend, and again, now I'm sorry, that was a good thing. See, I should have let you be my proofreader. I would have added something in there. There was, if I remember, I told them they had to spend close to $200,000, if I remember, because we had to do the retro commissioning process, which was, and probably of all the things that we did, minus the chillers. The chillers was another project that was not part of the energy audit. The chillers alone, yeah, the chillers was like, if I remember right, I told them to budget about $1.5 million on the chillers, and that was, and that's about what we spent on that, you know. But they did some additional things.
The chillers and the cooling towers?
No, they didn't change the cooling towers.
On the cooling towers, you just changed the motors.
No, we left the motors the same because they are on VFDs. They can operate lower. All we did is we put dams in them, in the hot water basins. So, because again, we were about to flow about half the water across that cell. And if you,
Cooling towers originally were sized
for 550 tons, almost twice the size.
so they don't need to use
All the water. So, yeah, so the surface area, yeah, so now you put in a dam in, right. So,
size the chillers.
yep, so we did all that.
So they were saving also energy through the cooling tower.
Yes, yes, but that was not even projected in what I told them in my ECMs. The only thing I gave them, which was not included in the savings, was if they converted from primary, secondary pumping to variable flow primary. If anybody here, if you know, I'll give you this free advice, you don't have to send me any royalty checks for this or anything. If you have a project that has primary, secondary chill water pumping, converting it to variable flow primary, providing your chillers can handle the varying flow, is the one greatest energy saver that you can do in a central energy plant. And the reason that is, and it's not, and again, I'll make a joke about it, but the manufacturers of the chillers, they tell you, they print out this thing and they show you that, you know, at 100% it's this kW per ton, and at 90% it's this. And so in theory, you know, if I'm running at some reduced rate, I should still be around, you know, 0.4, 0.43 kW per ton. Well, I'm the guy that goes and looks at the kW readings. I get them to print them out. And what we find is there's always a ghost load. You know, that's what I call it, a ghost load. They're producing, the chiller only needs, based on the water going back and forth, only needs, let's say, let's say of the 300 tons, they need 200 tons. When we go back and we start to look at what energy it needs to consume to make that up, they are spending 10, 15% more energy than what was predicted by the models that were done by the manufacturer. And that is, we found that it was even more inherent in when you have primary, secondary, where you have constant volume on one side, because now you have low delta T syndrome completely. So we found chillers that would say that would operate at, they're supposed to operate at 0.38 or 0.42, are now operating at almost 2 kW per ton. So I'm telling you, so did I answer your question?
Are the original chillers
That they had, the chillers were about 15 years old. They were not at the end of their life. They still had some life, but they saw that they could save energy and they had some capital money to spend.
What did they do with the original?
They sold them. They sold them, yep. That was one of the things. We got salvage value out of them. The only thing you can't get salvage value is out of pumps. Anybody else got any questions? Was somebody down? Yes, sir. Thank you.
And I've got a ton of questions, but I think what it keeps coming back to, the original design.
Yes, sir.
Designers are notorious for over-designing. Right?
Yes, sir.
You're padding the project. Do you think that's exactly where all the initial savings was? That the
Well,
fact that
yes.
it might have been
Well,
padded
and
by
again,
20?
what I didn't do is I didn't tell you the building was originally built not for this client to be a data center. A data center, a call center, it had a load. Well, when these particular folks bought the building, while they are financial, all their computing power is done, again, for safety reasons, was done in other places. Obviously, Florida has hurricanes, right? So the whole point of it being is that they did it, so some of the savings were there. That's why they had, and it was designed, if it operated like it was supposed to, it should have been an N+1. It now ultimately became N+2. So you're correct. And it wasn't intentionally over-designed. It was designed as something else. Am I getting the red flag or something? Oh, no, okay. Okay.
So everything makes perfect sense to me,
Sure,
my
yeah.
engineering mind. The one thing, you changed the motors on the pumps. I'm going to presume you changed the pumps as
Yes,
well.
sir. Yeah,
Went to a
of course,
variable
yes.
Primary. Did you have to change any of the existing hydronic systems, the steel piping or anything?
No,
And
because,
is there-
because again, what I did is I took that all to my advantage.
Because now you have an air handler with a chilled water coil in its size for a certain flow, so all of that.
That
can
is
be
all still the
reduced.
same. That didn't change. The problem is that out in the system, and there's Chuck right there. We found air handlers that were designed at 40,000 CFM were operating at 26. The first thing I went to the owner and I said, hey, before we get started, because we had him do a test and record first. I said, do you want us to do something with these? Do you want to get the 40,000? He goes, Al, everything is satisfied with the 26. Why would I'm asking you the question because I don't want you to come back later after I do this whole thing and you go, that air handler was supposed to do 40,000 CFM and it's only doing 26. I said, that's why I did this, so you can't complain. Yes, sir. Oh, with the crack units, they had this big, and the only reason they had the crack units were for the UPSs, right? So they throw off enough heat, there's no question about it. But they were having some flow issues, right? So they wound up running all three when only one was needed. So what we found is that the one the furthest away was not getting enough air, so we put like a little bit of a tunnel to scoop the air because the whole room wasn't being used, so we just told them to put in in the floor plenum to put a wall in to make sure the air got moving, and we had some additional outlets. Anybody else got any questions? Yeah, young lady, yes?
How do you see, in light of today's environment with indoor air quality being of importance, the commissioning process changing and how you're measuring airflows as it relates to aerosols?
Well, that was one of the things that we're starting to see where, this particular client is definitely on the cutting edge. While they put some needle point ozone depleting things in and they've been commissioned and whatever, they're still looking at it and they're in the process, and we fully agree they're starting to put in things that are going to read the VOCs in the space. Because CO2 is not only the culprit. Because CO2, I'm not going to sit here and preach. CO2, think about it. Anybody here that's, I think somebody was telling me about being a submariner on one of my conversations, and a guy worked for me. Submarines operate at a CO2 level at 5,000 or 6,000 parts per million, where OSHA says you can't go over 1,250. But I think the VOCs are the bigger issue. So if you don't measure it, you can't figure it out. That's the one thing. So I think it's coming, and I think you're starting to see people wanting to know temperature and humidity has now become, again, if the pandemic has taught us anything, it's taught us to look at where our problems are. Below 40% and above 60. Yes, ASHRAE says you should be between 40 and 60. But they found in most of these studies that I read while I was bored at home, still working by the way, but bored at home, about to still learn as much as I could, is what they found, and they all came from doctors that do work in third world countries where there is no air conditioning, by the way, and they found their highest rate of infection came when the temperature and when the humidity went above 80%, and it was worse when it went below 40%. So, you know, it's not only what the CDC says or whatever it is, there are other things out there. Did I answer your question?
Yeah, I'll talk to you.
Sure, I would love to talk to you. All right, we're done. I've gotten the high sign. I'm supposed to shut up now.